A very good morning to our lecturer, Dr. Suzairi. We are from Group 8 here to present about the experiment E2, Common Emitter Amplifier. These are my group members, Nurul Atika, me myself, Yoga Lakshmi, and Nur Ashikin. I would like to give a small introduction about the theory Common Emitter Amplifier. The common emitter circuit is mainly used as a voltage amplifier. It is used to enhance the weak signal received. For example, like the CE amplifier used in radio, it is to amplify the signal from the radio wave by running the weak signal in the base loop. So the weak voltage signal will amplify to become a stronger signal. The strong signal then interpret by device to produce the sound we heard. If the weak signal is running in the circuit without amplified, they may have signal lost. The input signal is applied between the emitter and base. And this is because the circuit need to forward biased at base emitter so that the electron can transfer to base and flow into the collector for amplifying purpose. Okay, next. Next, I would like to explain the objective of this experiment. The first one is to measure the input and output impedance of a common emitter, CE amplifier. The second objective is to determine the power gain of the common emitter amplifier. The third objective is to determine the phase relationship between the input and output signals of the CE amplifier. Next, I will move on to the equipments. We have used a 9-volt DC power supply, dual channel oscilloscope, digital multimeter, function generator, project board with connecting wires. Resistors, we have used 560 ohm, 820 ohm, 5 kilo ohm, 8.2 kilo ohm, and also 18 kilo ohm. And we have used potentiometer, capacitor with 22 microfarad 50 volts and 100 microfarad 50 volts, and finally transistor with BC108. And we can see in this picture, this is the circuit that we have arranged with all these equipments, and we have connected the wires to the project board using the resistor, capacitor, transistor, and so on. Next, for the procedure, we have 5 parts in this experiment. For the first part of the procedure, the input impedance Rin of the CE amplifier. We have arranged all the equipments according to the figure in this picture, but we have removed the R out, which is the 5 kilo ohm resistor. Then we connect the point A and B with a jumper wire. The frequency for the function generator was set to 1 kilohertz. Then we observe the output signal at point C and D using oscilloscope. And then we reduce the amplitude to 70% of the distortion value. Then we record it as the voltage output V out. Next, we disconnect the jumper wire and measure the voltage at point A and point B using oscilloscope. Next, for the part 2 of this experiment, the output impedance R out of the CE amplifier. We have inserted back the R out 5 kilo ohm resistor back to the circuit, and the potentiometer is adjusted until V out is half of the value we obtained from the part 1. And then we remove the R out from the circuit, and its resistance is measured using a digital multimeter. Next, for the third part of this experiment, the power gain of the CE amplifier, we have calculated the input, output powers, and also the power gain of the amplifier based on the table 1. And here are the equations that we have used to calculate the input power, output power, power gain, and power gain in decibel. For the part 4 of this experiment, the effect of a shunt capacitor C3, the shunt capacitor C3 with the 100 microfarad is removed from the circuit for part 4, and then we calculate the output voltage. For the fifth part of the experiment, the phase relationship between the input and output signal, we have placed back the capacitor C3 to the original position in the circuit, and then we have used both channels AC and also DC on the oscilloscope, and we used to display the input and also output signals of the CE amplifier. And the phase difference between the two waveforms is determined then. For the next part results, I will pass to my group mate.
Okay, hi. This is the table of the result that we measure. So from part 1, we measure the input impedance Rin of the CE amplifier. So VAC is 150, VBC 54, V out 1.92, and Vx is. So from part 2, the output impedance are out of the CE amplifier that we measure. So from the table, V out is 0.96, R out 2.002 kilo ohm. So from part 4, The effect of a shunt capacitor C3 is V out equal to 3.19 volt.
So this is the analysis for part 1. In part 1, we need to calculate the voltage across the input resistor and then input current and then input resistance, and the last one is voltage gain. So after we disconnect the jumper wire using the oscilloscope, we need to measure the voltage at this point. So the first one is voltage across the input resistance. We got 4 millivolts, and then for input current we got 4 times 10 to the power of negative 6 ampere, and then the resistance input resistance we got 2.25 times to 10 to the power of 6 ohm, and the last one is for voltage gain. So in voltage gain we got 0.213 volt. So next is analysis. This is for part 3. In this part, the power gain of the CE amplifier based on the value in table 1 that we collect, and we need to calculate the input and output powers and the power gain of the amplifier. So the first one is input power. We got 0.0405 watt, and then for output power we got 1.843 times 10 to the power of negative 3 watt, and then for the power gain we get 0.0455 watt, and the last one is power gain also, but this is indecibel. So we got minus 1.342 decibel. So next, okay, this is the picture for our part 4. The effect of shunt capacitor C3. So after we remove the shunt capacitor from the circuit, we measure the output voltage and we measure the output voltage, which is V out. So this is the real picture for part 4 that we obtained. This is the waveform look. Next. Okay, this is the part 5. We need to determine the phase difference between the two waveform, the phase relationship between the input and output signal. So we use the both channels on the oscilloscope to display the input and output signal of the CE amplifier. So this is the result that we got for the waveform obtained. So next, here is the graph we sketched in part 1 using result in table 1. We have drawn the table. We have drawn the DC load line analysis graph for common emitter configuration, the IC, output current, and voltage. DC load line is drawn at output characteristic. So we will get the slope line, and that line is called the DC load line. On the same graph, we also need to sketch the V input and V output wave signal and their amplitude based on the experimental setting. So if you can see, this is the Q point, which is the coordinate is 5, 2.
Okay, for the next part, for the task and questions, we have 5 questions to be answered. And for the first question, the common emitter circuit is used mainly as the answer is voltage amplifier. And for the second question, the input AC signal is applied between the answer is emitter and base. And for the third question, the AC voltage gain is the answer is high. And for the fourth question, the output impedance is the answer is high. And for the last question, give 2 applications of the common emitter in daily life. The answer we gave is radio and also microphone. Okay, next I will pass it to my friend to explain about the discussion.
For discussion, in part 1, we have sketched the DC load line analysis graph for common emitter on a graph paper. And at the same time, we also have determined the Q point, which is 5, 2, transistor operation. In part 1, the calculation are based on the table 1 that we have obtained from the experiment. So we calculate the voltage AC by VC minus VE. So for the next part is part 2. According to the Ohm's law, V equal to IR, we have reduced the value of V output into half. So we noticed that the reading for the resistance output was dropped due to the impedance or resistance level comes from the truth that the output is used from the collector terminal. So in part 3, we have calculated the input and output powers and the power scale of the amplifier. So next, in part 5, V output is 1.92 volt. So this is due to the very high currents to flow through the lines. It has a very low impedance when C3 has removed. The signal generator following resistance 3 will cause a voltage drop. So if you can see, for the first voltage we got 1.92, and then it will drop to the 0.319 volt. So for the last part, the phase difference have been calculated using the formula given in the manual book. So we calculate the phase difference between input and output signal. So the result we got 3 360, sorry. So next, okay, during conducting the experiment, we need to be followed and to be done all the precaution in all the experiment. So the first one is, we need to connect all the components correctly and neatly to make sure all the components are not touching each other on the board. So second is, we need to take in several reading and calculate the average for the result to get the accurate reading. So the last one is, this is very important. When we remove and insert the resistor, we will make sure the power supply should be turned off to stop the electric shock. So this is very important to be followed in conducting the experiment. So next, for conclusion, I will pass to my group members.
Okay, for the last one, conclusion. Number one is the input impedance of a common emitter CE amplifier is 4 times 10 the power of negative 6 ampere. Second, the output impedance of common emitter CE amplifier is 0.002 kilo ohm. Number three, the power gain of the common emitter amplifier is 0.0455 watt. And number four is the phase relationship between the input and output signal of the CE amplifier are exactly 180 degrees out of phase of each other. And number five, the last one, common emitter amplifier present high voltage and current gains that enhanced by the presence of derivation capacitance in the emitter branch. Okay.
That's all for our presentation for today. Thank you.